Hello. So in this video lecture we are going to learn about or understand one of the most important applications of regression analysis, which is prediction. In regression analysis we are actually looking into the relationship between the independent variable x and the dependent variable y. Through regression analysis we are trying to measure the extent of effect that variations in this x variable has on the values of y. So once you have estimated the regression equation based on the sample at hand, you have estimated the sample regression function. Since we do not have the entire population's data in our hand, it is almost impossible to estimate the population regression function. So the sample regression function acts as an estimator of the population regression function. Our regression analysis will be most efficient or most apt when the SRF is as close as possible to the PRF. And the criteria for ensuring this is the ordinary least squares or the OLS, right? So this is what we have been going through since the beginning of these econometrics lectures. So now, once you have estimated the sample regression function, we are saying that we are going to use the estimates that have been calculated by us based on the sample for prediction, right? Prediction means we can answer a question that if the value of x is equal to, say, x naught, what will be the value of y? When you're dealing with historical data or time series data, we even use the term forecasting. So if you have done a time series analysis or a regression of data regarding to the stock market values, or maybe data you have been looking at a regression that explains the value of gold prices, you can use the regression estimated by you to predict what will be or forecast what will be the value in the stock market of a certain share in the future, or maybe the gold prices in the near future, what will be the price. So usually we use the term forecasting when we are dealing with historical and time series data, and otherwise cross-sectional data we more generally use the term prediction. We are trying to predict what will be the value of y for a certain given value of x. Now, when it comes to prediction, you can think of two types of prediction. The first type, we call it the mean prediction, is you're trying to predict the conditional mean of y corresponding to the chosen x. That is, remember your population regression line is called the conditional mean line or the conditional mean function. If you remember from our example, okay, maybe I can just draw and show you. This is, I'm going back to the hypothetical example of 60 families that we had. So we had weekly incomes as our independent variable, and weekly consumption expenditure was my dependent variable. I'm calling it C to the power n, that stands for consumption, right? So we were trying to estimate the relationship between incomes and the consumption expenditure. Now in this hypothetical example, what we had done was there were around 10 to 12 x values, and for each x values we had a few corresponding y values. Okay, I'm just drawing this freehand. So it was something like this. Here the dots, red dots represent the entire population, okay. So we had around 10 to 12 X values, and corresponding to these X values we had different families having this X values as in different income levels, and corresponding to these income levels there were more than one or two families, and each family's consumption expenditure was plotted. Remember this, in the example that I'm talking about we had 60 families in the total population. So the population regression function was estimated by finding the conditional mean value for each level of X. Now this is the population regression function that I'm talking about. This is PRF. Okay, one second. This is your PRF. Now what happens is, in real life, in practicality, not all of the population is known to us. So now what happens is, among the 60 families we probably have data related to only something like this, right? So we probably have only a handful of these values in our sample that is chosen. Since the population is not known to us, based on the sample, I have denoted the sample values in blue, okay? So based on these 1, 2, 3, 4, 5, 6, 7, maybe 8 or 9 values, what can be done is we use the OLS criteria to formulate my SRF. Right? If you remember, it is yi is equal to beta 1 hat plus beta 2 hat xi plus ui hat. This was my SRF function. So what is known to us is only the line in blue. This is what we have estimated. This is our sample regression function. Based on the sample regression function, you can think of two types of prediction. You can predict what is the conditional, okay, I'm using a third color, maybe green. You can try and predict what is the value of the conditional or the mean value of y given x equals to x naught, right? Or suppose we had something like this. This would be called trying to predict the conditional mean. Trying to predict the conditional mean of y given the value x naught is called your mean prediction. So that is one type of prediction that can be expected. Another expectation or another possibility is that you're trying to predict the individual y value. That is, given x is equal to x naught, you're trying to find out what is this individual y naught value. Right? So this would be individual prediction. One is the mean prediction, one is the individual prediction. So in the mean prediction, you're actually trying to estimate or trying to find out a line on the PRF using information calculated in the SRF. And in individual prediction, you are trying to estimate the individual y naught value, the observed y naught value, using the information that has been estimated, the things that have been estimated in the sample regression function. I hope the difference between the two is clear to you. Right? So, like I was saying, you can either try and predict the conditional mean of y corresponding to the chosen x. Like I said, you're trying to predict the point on the population regression line using information from the SRF. Or you can try to predict, the second type of prediction is to predict the individual y value corresponding to a given x. This is called the individual prediction, right? Now, mean prediction, for a given x equals to x naught, you want to predict what is the conditional mean of y given x naught. Expectation is also read as mean, remember? So you're trying to predict what is the conditional mean of y given x's value x naught. Now the point estimate for this x naught will be, take your sample regression function where you have your beta 1 hat and your beta 2 hat, put the value of x equals to x naught on the right hand side, and the value that you will get will be your y naught hat. It will be an estimate of the true, this would be a point estimate. The y naught hat here that you calculate here will be an estimate of the true point on the population regression function, right? Again, previous classes we discussed how we can have either a point estimate or you can find an interval estimate, right? So to find a confidence interval at say alpha equals to 5% or 1% depending on the level you have chosen. So you can find the 95% confidence interval by using the t statistic, right? This is the t statistic. T statistic is the estimated value y naught hat minus the mean value, which is divided by the standard error, right? So the formula that shows this is the formula for the 95% confidence interval or 99% confidence interval. That depends on the value of alpha you have chosen, right? Remember, the standard error of y naught hat to be put in the denominator of calculating the t statistic will be the square root of the variance, and variance is given by this formula. I'm just writing this for your information. I don't think learning these formulas by heart is required, okay? But just understand how we get the t statistic. T statistic is the estimated value minus what is the predicted value, whole thing divided by the standard error of the estimated value, okay? This is true for any t statistic that you are calculating. Individual prediction, we are given the value x equals to x naught, and we are not concerned, we do not want to find the point on the population line. We want population regression function, we want to find the actual y point. So we want to find the actual individual y naught. Again, the best linear unbiased estimator of this observed value y naught remains y naught hat, that is beta 1 hat plus beta 2 hat times x naught, okay? So in both cases, mean prediction as well as individual prediction, my best point estimate remains the same. But when you're trying to find an interval estimate or a confidence interval within which the true value of y naught is likely to lie in, again you will go through the process of calculating your t statistic, which will be y naught hat minus your predicted y naught value divided by the standard error, okay? The standard error in this case will be different. Standard error is the same as standard deviation, that is square root of variance. Look at the variance over here. The variance here that we want when we are talking about individual prediction is variance of y naught minus y naught hat, that is observed y naught, actually observed y naught minus what has been estimated y naught hat. And this is the formula for variance. If you notice, the variance in the case of mean prediction was only 1 by n plus x naught minus x bar whole square divided by summation xi square. In this case, in individual prediction case, we have an additional 1 plus the inside the bracket. So the variance in the case of individual prediction is larger, which means the standard error in the case of an individual prediction will be greater, which automatically will mean that the confidence interval that you calculate at any given level of alpha will be wider in the case of individual prediction. That will make sense because in the case of individual prediction, you are also taking into account the UI or the deviation of observed Y from the estimated or the calculated mean, right? So it makes sense if you think over it. Point to be noted is a confidence interval that is calculated for individual prediction will always be wider than the confidence interval for mean prediction. I have not given you too many formulas because it is not required to be learnt by heart. You just need to understand the concept, okay? In fact, I prefer you to understand it more in terms of this diagram that is shown here. If you notice, for the value in the book, this is directly from your Gujarati book, so after you listen to this lecture, please do read chapter 4 of your Damodar Gujarati book. They have solved it based on an example, and they are trying to predict the value of conditional value of y given x equals to 20, okay? And when it's mean prediction, the point estimator value is 14.46, and when you're talking about interval estimate, they get the interval estimate as 15.82 to 13.10. So that is the confidence interval within which the true value of y naught is expected to lie, okay? With 95% confidence. A 95% confidence interval means that if you take several samples and in all these samples you build such confidence intervals such as 15.82 to 13.10, you calculate it. In 95% of these cases, the true y naught or the true conditional mean of y will tend to lie within the calculated intervals, right? Now, in the case of individual prediction, using the same example, when they've calculated, remember the point estimate, whether it is individual prediction or whether it's individual prediction or mean prediction, the point estimate remains the same. That is, for both the cases, the best linear unbiased estimator is beta 1 hat plus beta 2 hat x naught. So the value remains the same, but the confidence interval is wider in the case of individual prediction. For the value x equals to 20, when they calculated the confidence interval, they say it is 16.91 to 12.01. Right? Again, if your alpha level is 5%, then these are called your 95% confidence interval, and the 95% level or 5% level of significance or 95% confidence interval would mean that if you take many such samples and calculate confidence intervals range from 16.91 to 12.01. Similarly, if you calculate for all these samples, if you calculate confidence interval for x equals to 20, individual prediction, in 95% of the cases you will successfully create an interval which contains the true value y naught. Okay. So the dotted line and the continuous lines are called the confidence bands. Okay, this has been plotted by calculating the confidence intervals for different levels of x. Like we did for x equals to 20, they have calculated it for x equals to 18, for x equals to 16, x equals to 14 and so on. And then they have joined the lower limits to get the upper limits separately to get these bands, right? See, for mean confidence interval for mean y, and the dotted lines is confidence interval for individual y. You can see that the sample mean here is x bar. You can see in this case that the sample mean here is x bar, and the width of these confidence bands in the case of mean prediction as well as individual prediction is least or the most small when x is equal to x bar. As you move further away from this mean value, sample mean value, the confidence interband's width is increasing. Okay, just understand this point. No need to calculate for each and every point. It is true in any example that you come across. Okay, so as you move away from the mean value of x to the right or to the left, you can see that the confidence band for both cases, mean y prediction as well as individual y prediction, the confidence band is becoming wider and wider. So wider the confidence band, lesser is the reliability, right? Lesser is the accuracy with which you can find either the mean y or the individual y. So for any regression line, there is a fall in the predictive ability of the regression line as you move away from the sample mean value. This should be kept in mind every time you extrapolate or try to predict what will be the mean y naught or the individual y naught, especially if it is further and further away from the sample mean x, right? So that should be it for prediction. If you have any doubts, please do get back to me.